This is the summary created from the video. Lecture 47, Containers Container-Based Virtualization Kubernetes Docker Container. In this lecture, we explore the advantages of DC microgrids, which avoid multiple power conversions between AC and DC, making them more efficient. These DC microgrids are often operated in isolated mode without a grid connection for simplicity. We begin by analyzing a standalone DC microgrid system, a common and feasible scenario. This basic architecture includes photovoltaic and wind sources, diesel generators, batteries, and supercapacitors to meet the demand for rural electrification. A control strategy is implemented to prioritize renewable energy sources, optimally utilize storage, and use the diesel generator as a backup. Battery charging and discharging are governed by specific state of charge thresholds to balance load and generation effectively. Simulation results demonstrate the impact of load demands and battery state of charge on diesel generator operation. Batteries and supercapacitors handle transients, while the diesel generator kicks in when renewable generation is insufficient and battery levels are low. Moving beyond a single system, we explore the interconnection of two local DC microgrids, which enhances energy security and renewable utilization. Excess renewable energy from one grid can support shortages in the other, leading to cost reductions and increased reliability. The system consists of two autonomous DC microgrids with different voltage levels, interconnected via a dual active bridge converter DABC that enables bidirectional power flow with galvanic isolation. A communication-independent control strategy is proposed, managing power flow between the microgrids based on overloading, underloading, overcharging, and undercharging conditions. The strategy covers battery management, MPPT operation, and load shedding control. Simulation results showcase the operation of interconnected DC microgrids with different photovoltaic capacities, battery sizes, grid voltages, and load configurations, highlighting the flexibility and adaptability of the proposed system. The effective autonomous control manages sources and storage through bus signaling, maintaining bus voltages within allowable ranges without the need for communication between buses, ensuring high reliability and flexible power sharing. Overall, the analysis demonstrates the feasibility of DC microgrid operation in isolated mode and the benefits of interconnecting multiple microgrids operating at different voltages, enabling mutual support and optimized renewable energy utilization. In conclusion, DC microgrids offer advantages in efficiency, energy security, and renewable integration. The presented control strategies and simulation results pave the way for effective and reliable implementation of interconnected DC microgrid systems. Please stay tuned for more summary videos.